Okay. I'm going to talk about the Shiny app for sample size or power calculations for trial design with hierarchical endpoints. To set this problem up, to tell you what is hierarchical endpoints, this is really usually composite endpoints combine several time to events to be a time to first events, but it's sometimes the less important outcomes might occur first. So by contrast, hierarchical endpoints take relative importance into account, and it can incorporate multiple types of outcomes, time to event, continuous, binary, ordinal, and count. So let's say you have K hierarchical endpoints, and there's um, two treatment groups, A and B. A is active, B is control over standard follow-up time. So for hierarchical endpoints, you first compare the first endpoint that's rated as the most important. If it has a better endpoint, then the pair is a win for treatment A. And then if it cannot be determined, then you go to the next one and so on, going through the hierarchy. Then at the end, so either the pair is either win or lose or tie. So there are several measures that's usually popular to be used to assess treatment effects. One of them is called the win ratio. It's basically defined as the probability win divided by the probability lose for treatment A. I have this math formula here. This win ratio sometimes criticized because it doesn't take the ties into account. So there's another one called the win odds. Add a half a probability tie in the denominator and the numerator. And for both the measures, the null hypothesis is testing whether the value is equal to 1 or not. That's if it's equal to 1, that means the two treatments are the same. So that's a null hypothesis usually for the trial. So both of these are relative measures. There are other measures also proposed that's called a net benefit and/or for the net benefits, rather than taking the ratio, you basically take the difference between the probability win or the probability lose. And for DOR, it's called the desirability of outcomes ranking. It's basically just the probability win plus half of probability ties. And the null hypothesis for net benefit is testing that equal to 0. For the DOR is testing that equal to half. All the null hypotheses are really kind of equivalent, but they have different interpretations, and some people prefer one over the other. So the typical cohesion design, a trial with hierarchical endpoints, sometimes how do you pick the magnitude of win ratio? Suppose you're using win ratio, and how to justify it. How many endpoints should I use? How much does the order matter? How to compute the power sample size? How can I compare different scenarios quickly? So those are issues we're really facing. So it's not so easy to do. The other thing is that typical scenario is that we only have information marginally, either in the literature or preliminary studies, like say you have 3 hierarchical endpoints, time to event, or hospitalizations, or change your KCCQ, that's quality of life. It's really based on those marginal data. You really don't know what overall win ratio is. So what we set out to do is that we are making a strong assumption, but let me get to the sample size here. In past on the paper published, you do have a formula, so you need those magnitude of win ratio. And based on what you get from the physicians, usually you don't have the overall win ratio. So our solution is what we do is we make a strong assumption, and then we did a lot of simulation studies and find out that assumption doesn't really matter. It's that we can actually express the win ratio magnitude as a weighted average of the marginal win ratios, because you can get those marginal win ratios from the literature. Of course, you make a little bit of assumptions on those outcome variables, but this way give you a way to come up with overall win ratio and justify it. This same thing works for the win odds. We come up with this new formula, and then how you compute it from the marginal information. And I'm not going over the details, but what you can see is for net benefit, and the door. You can see the formulas here. So what's the challenge about this is that you see there's a lot of formulas. You need to be able to have a program that accommodate all type of endpoints and any number of endpoints. So how do you program this and make an app so that's easy to use for people? So this is where Dylan is going to come in to show you how this works. So I'm going to stop sharing and let him share his slides and show you how this is done.
Thanks, Huiman. So my name is Dylan Thibault. I'm a biostatistician at the Duke Clinical Research Institute. And as Huiman said, my task was to come up with the Shiny app. And so the purpose of the app was, as she said, we wanted to make a tool that you could quickly calculate sample size or power for hierarchical endpoints. I needed to support multiple endpoint types like time to event, binary, continuous, count, and ordinal outcomes. We also want to provide as much detail as possible. So like probability of ties, marginal probability of ties, the marginal win statistics, in addition to the power and sample size and the overall like win ratio or win odds. Some of the key features is we wanted to allow multiple endpoints to be entered in a sequence. And since they were entered in the sequence, it supports the structure of the hierarchy and it ensures that the inputs are processed in the correct order. We also wanted to allow customizable outputs, so users could output just the win ratios, win odds, net benefit, or DOR, or all four if they wanted to, and also allowing the user to download the results so they can have it saved locally. Some of the challenges of this, the first one is just allowing the flexibility for inputs of multiple endpoints. And so the app needed to allow users to input any type of endpoint, and some of these have very different required inputs. And so the solution to do this was to use a dynamic UI generation in Shiny. And so the user is able to select the input they want to enter, and then it then populates the fields relevant for that endpoint type. And this is also relevant for entering specific input types for Group A compared to Group B, as you'll see in a demo. We also provided some conditional logic checks to trigger Shiny alerts to give the user the best experience possible. The other challenge was maintaining the order. And so in order to do this, we use reactive values to store the list of the endpoints in the exact order they were entered. And so by doing so, we ensure the function would iterate over the list of the endpoints and aggregates the results step by step. Last, we just wanted to allow the app to process any number of endpoints. And in order to do this, we created a function which then iteratively processes each endpoint and the list that is dynamically updated each time a user adds a new endpoint. We also then render the information for the user to see as each one is entered. The results for these endpoints are aggregated step by step, ensuring that even if the user adds a large number of endpoints, the app can process them efficiently. Skip through that. So for the styling of the Shiny app, we just use the BS-lib package, which uses custom bootstrap themes and using the Duke branded colors, and also using thematic to maintain consistent styling across the UI elements. Some of the next steps that we want to do, we've considered maybe incorporating large language models to provide a user with summary that's unique to their endpoints they've entered. So it kind of just is always custom. And then also adding the main R functions to GitHub so they can be used standalone outside of the Shiny environment. So now we can do a quick demo here. So this is what the app looks like. It's hosted on shinyapps.io. So the user can go to the endpoint and you can select the endpoint you want. So for this example, we'll do time to event. You would enter the follow-up time that's relevant to your study, so the units are relevant, but this would be 2 years, we'll say. The winning direction would be larger or smaller, so we'll do larger. And you can enter a probability for the group or a hazard ratio compared to the reference. We'll just do the probability in A. And we'll say 35% for that, 30% for the reference. And we add it, and it updates down here to kind of show what you've entered. Next, we could do a continuous outcome, larger value. We'll just enter the mean for that population. We'll say 30, 20 for B. Standard deviation could be 5 in both of them. Threshold to win, we'll say, is 10. Add that. The last one, we'll just do a binary outcome. We'll say smaller value is better. We'll enter the probability for that group. We'll say 10% versus 15. And then we're going to assume a 0.05 two-sided type 1 error, randomization's equal between the two groups. And then we'll give it power and ask for the sample size. So you can see it'll give you the sample size for all 4 measures, the overall win ratio, win odds, net benefit, and door. It shows you the endpoint details that you've entered. We also have a hyperlink for instructions if you need instructions. And then you can then download the results. Go ahead and open those real quick. And you can see we give you the marginal probability of ties. So for the 3 endpoints, they're listed in the sequence they were entered. Overall, marginal win ratios, marginal win odds, and then it gives you the sample size. And then you can reset it, or you can kind of keep playing around with it. So you can just keep changing numbers and updating as you'd like. You can switch to give it a sample size estimate. And then it'll give you the power instead. So that's it for the Shiny app. If anybody has any questions.